in that case, using regression or support vector machine may give you a better result. So yes, that is something that you have to keep in mind. Yep. Another thing about tree-based method is the fact that you have various interpretation tools. So firstly, you have a tool that is the tree itself, like how you make decision. That's why we call this algorithm decision tree. And also with this decision tree, you can write something called partition regions. Actually, partition regions, how should I say this? It's actually very similar to if you were able to plot, like let's say, providing the plot and highlight your data sample. For example, if you have 5 people falling into region R1, 2 people in R2, and maybe 1 person in R3, this is pretty much like you are partitioning the boundary decision of the scatter plot of the data sample. Partition region is used to represent, like, according to the distribution of your data, how should you partition them into classes. And this is like, you can imagine this as a top view of the tree-based algorithm. Because for example, let's say if you classify the patient into normal class, hypertension, and diabetes. Let's say that of course, they are your target class. So yes, they are corresponding to each of the region in the partition region. But usually, the partition region will also encode another information. That is how widely spreading one class is with respect to the training samples. For example, if you feed, let's say, 1,000 samples into this tree algorithm, and it gives you the class for each person in that 1,000 sample, then you can also write some kind of partition tree to say that, okay, people around up until this range, usually they will have something like, maybe this could be blood sugar, blood pressure. Like in this direction, and in that direction is the sugar level. As you can see, of course, those samples has been classified as normal or in the region 1. They don't care about the sugar level. But if you can partition it this way, that also kind of implies that, about 50% of people probably falling into region 1. This may not be as clear right now, but I'll show you another example. Okay. This is probably what it should look like. So let's say you have data belonging to 2 classes, the red and the green. If you were to draw the partition representation just like previously, probably you would do something like, and it depends whether or not you want this to be too separated, but usually they will. So you have region 1, region 2, region 3, region 4, something like that. And you may say that, oh, but it's like at the end, region 1, 3, and 4 are the same. Yes, there are ways to combine them, but it is like these will be the kind of regions that you have before your algorithm learning is finished. After you finish, you can say that, okay, region 1, region 3, region 4 actually belong to one class because, yes, you have information about your data sample. You can group them together. Okay. But we will see how shall we get this region and making this decision tree. Okay. So maybe, first of all, I'll introduce you with this data sample, how decision tree would work. But before that, let us, how should I say? maybe I'll show you first how it works and then go back to the mathematics behind it. Okay, so firstly, when you are given data set, what the decision tree would do would be that they will making a decision node, or what we call it a root node. So we have a decision node, a root node. Root node, when we talk about node in decision tree, they usually refer to like steps that you perform with your data. For example, your data may be 100, and that 100 data samples may be corresponding to one operation, that is your one node. So your first step in here will be the decision node. That is, sometimes we also call it the parents node. And in this decision node, you will have to make a decision of what is your child nodes. So in this decision, it's like you are having a whole set of data, and you will first start to split the tree. And let's say we are only interested in binary splitting, so we only classify 2 classes at a time. So firstly, it will start off with finding, maybe sorting the value on x-axis, or maybe x0 or x1. You can begin with one of them first and the other later. But in this case, let's say I start off with x0 first. So when I start off with x0, I will then sorting the value of the samples along x0 axis and see when I can make like a decision line. And that decision line is made when you are able to put samples in a certain class together. For example, in this case, if I start sorting from 0 to maybe up here, maybe some positive value like 20. And then as I sort from 0 to maybe 1, I get group of data point belonging to one class already, that is the red class. That is when my decision node are able to set up the child nodes. One is a left child node, the other is a right child nodes, because one is on the left side, the other is on the right side. So with that decision tree, we are able to provide 2 nodes, left node and right node. And maybe I'll just put the one at the top as the root. Sorry, right and root look very much the same. I'll put it as D node. So it's a decision node. So this left child, they all pure because their data samples belong to the same class, that is class red. So we say that, okay, so because they are pure, we will assign this left node as a leaf node. And with these leaf nodes, if you get all the data sample belonging to one class, so you can say that actually whatever data point that you know, once you make some kind of thresholding, let's say with the value 1, and if it's less than value 1 on x0, then probably they should belong to class red. So you can use the majority vote of all the class that are pure to define what class that you would classify your data sample to be. So that leaf node, once you run some kind of majority algorithm, majority decision of your nodes in your left, maybe it's red, that's your leaf node. So leaf node is like, will be the kind of node that you derive your prediction. That's what probably I would say. Then for your right node, you can see right nodes, you have data samples that are mixed between classes. Therefore, you assign it as a new decision node. And then with this decision node, you would do the same. Like you then start to looking at these region, and then you start to partition it again. For example, since you already said that these data sample that you previously classified as leaf is kind of like done already, like you don't want to look at it again. So for your decision node, that is like your new decision node now, it have the mix of data point, therefore you would do the same. You will start partitioning. You start splitting, that's what we call. You start splitting it, but this time you probably start from maybe x0, but this time from value 1 to maybe something like 20 plus, and you sort it again. And maybe you will find that at about this line, you can separate data into two sets again. But this time, for this region, your left node will be the one that is of mixed sample, and the one on your right will be the one with pure. So for that, your right nodes would then be the leaf nodes, where you can use some kind of majority to say that, okay, all these data sample, if it's beyond, let's say x equal to x0 equal to maybe 15. If it's beyond x0 equal to 15, then it should belong to class red, because the majority of the samples are in that class. But now, what you have next is your left node that is now become a new decision node. So again, you now know it's a decision node, then you will start to do the same thing again, that you find a place where you want to split your data so that one area has the pure nodes and the other area maybe having some mixed node. Again, your left and your right. But this time, as you can see, you can no longer splitting anything in between. For x0, all you can do is to, maybe I'll change the color a bit. You will be able to look at this area and maybe start sorting along x1 instead, because x0 no longer give you like a splittable area. So you go to the next feature is maybe x1, and you start sorting along x1. And for that, maybe around x1, maybe equal to 10 here. Now you have left and right that are full of pure nodes. Then you stop, because they are now having two shouts that are leaf nodes. That means you don't need to go further and try to split them, because they are pure. There's no mixing of samples between classes, so you're done, right? So you are end up with two leaves. And now you can do some kind of majority vote. For the one, maybe I'll put this way, as if we are able to rotate this, that will be my left and that will be my right. For this, both left and right are leaf node, but the majority of my left is red class, and the majority of the right is the green class. So yes, you can still use this decision tree. I mean, even you use decision tree to infer. It is like if your input sample have x1 and x0, it depends on where it falls to. Let's say if your input sample is like this purple dot, it fall into here. So it will fall into the categories of the region of your leaf node here, right? So you can start to classify it. Or if it's fall into this area, you can still classify it. It actually belong to the left, and it still should have the red nodes. Or if you have another sample that belong to maybe the middle area here, when you do the classification, so of course, if you do follow the thresholding that you've done before, then it should have a green class. So this is how you will construct or maybe do some what we call the tree learning. So you learn your decision tree to do the to do the prediction, but the way it's done is like it depends on how you split your data